Hello, Precalculus students. This video will be covering a practice final exam for Math 112 at Rutgers University. The questions that we will be going over are sourced from Professor J. Kennedy. We're starting at question 2 because I was not sent question 1. But question 2, it says, write the following in order from smallest to largest. Now, assuming we don't have a calculator, we have to remember that logarithms extract the exponents. So, for log base 3 of 25, we want to find the base 3 that is around 25. So I know 3 squared equals 9. I know 3 to the third power equals 27. 25 must fall between 9 and 27. So this logarithm will be between 2 and 3. Now, for log base 2 of 30, I know that 2 to the fourth power is 16. 2 to the fifth power is 32. 30 falls between 16 and 32. So the logarithm will be between 4 and 5. And then lastly, log base 5 of 25. I can represent 25 as a base 5. So that's log base 5 of 5 squared. There's that invisible exponent of 1 on the base 5. So we do the exponent of our argument over the exponent of our base. So that's 2 divided by 1, which is 2. 2 is before a number between 2 and 3, and then the number between 4 and 5 would be after both. So the order would be log base 5 of 25, then it would be log base 3 of 25, and then it would be log base 2 of 30. So that here is option 1. All right, question 3. We have this trig function, and something we can remember is just the general form. I'll use sine because sine's used here. Y equals a times sine of b times x minus c plus d. A is your amplitude, or at least the absolute value of a, because it's the positive version of a, is the amplitude. C is your phase shift. D is your midline. And B indirectly gives you your period. You would have to use the formula. Period equals 2 pi over b. Now the reason I like to use this form is because it goes in alphabetical order, right? A, B, C, D. So it's easy to memorize. But you could always just write this out on your test and then just match up where each coefficient or constant is. So B is in the K place, so K is B in this case. This B is in where the C place is, right? So that's your phase shift. And A is where the amplitude is. The other thing you could think to yourself is, when you're multiplying on the outside, that's your amplitude. That's the vertical distance from your midline to your extrema, your maximums and minimums. The multiplier on the x is that constant term that gives you the period, 2 pi over b. And then this is a horizontal shift or a phase shift, and it shifts the function left and right. So, first thing I think to myself is, where's my midline? My midline's at 0, so that's why there's no plus. C or plus D on the outside. The next thing I think to myself is, what's one full period? One full period, we're trying to look for one full cycle. So it goes down, around, and back to the midline. It would restart right there, the cycle. So at 4 pi. So your period is 4 pi, and we know the formula is period equals 2 pi over b, but in this case k is in the b spot. So I'm going to use k. We said the period was 4 pi, because it looks like we started at 0, and we're going to 4 pi. 4 pi minus 0 is 4 pi, equals 2 pi over k. I can multiply by k on both sides, and I could divide by 4 pi on both sides. So I get k equals 2 pi over 4 pi. Pi cancels out. 2 over 4 is 1/2. So our k is 1/2. The phase shift is where you're starting the cycle, right? And how you would shift it. This sine function starting at 0. So we could say that there was no phase shift, or that your b is 0. And then lastly, your amplitude, we said, is the vertical distance from your midline to your extrema. So the amplitude is equal to 6, right? But something to be careful of is we also have to consider the trend of the graph. Sine typically starts at the midline, goes around, and comes back, right? Going up. So that would be a positive sine function. But this one reflects over the x-axis. So it starts at the midline, goes down and around. That would be negative sine x. So even though your amplitude is positive 6, your a, the leading coefficient, will be negative 6. Okay? So that's just something to be careful of. Find the reference number and terminal point for t equals 29 pi over 6, if necessary. So 29 over 6 is approximately 4.83, right? If you don't have a calculator for this portion, you could just, do your long division. We know that this would be 4, and then subtract 24 is 5. Bring down the 0.0. 6 goes into 50. 8 times. So then you would subtract 48, and you get 2. And then you bring down the 0. 6 goes into 20. 3 times. And then you'd subtract. Regardless, now we know it's going to be 4.83, which is greater than 2 pi. So greater than 2. I don't mean to say 2 pi. It's greater than 2 because we're ignoring the pi right now. So that means that it is not between 0 and 2 pi. So what I'm going to do is I'm going to find the coterminal angle. So I'm going to subtract 2 pi, which is essentially saying subtracting 12 over 6. 29 minus 12 is 17. Alright. I will subtract 2 pi again. So another 12 pi over 6, which is 5 pi over 6. And 5 pi over 6 does fall within 0 to 2 pi, right? Because if you follow your 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. That's in the second quadrant, right? But pi over 6. So now we want to find the reference number or the reference angle. That is the positive acute distance from or angle from the coterminal ray in 0 to 2 pi to the x-axis within the respective quadrant. So this is pi here. I'm going to do pi minus 5 pi over 6. Which is essentially saying 6 pi over 6. And you get pi over 6. Which you could actually see because it's about the same angle as pi over 6. So the reference number is pi over 6. And then we have to think to ourselves on the unit circle, where is, what is cosine and what is sine, right? Cosine, sine at pi over 6. So you might memorize, and we have pi over 4 in the middle for splitting it in half. We would have 3, 2, 1, 1, 2, 3. All of them are divided by 2. All of them have a square root in the numerator. You don't have to include the 1 for the 1 because square root of 1 is just 1. So if that's the same reference angle as pi over 6, you could use those same values, radical 3 over 2, 1/2, but you have to think it's going to be negative positive a point in quadrant 2, right? Or you could also think of it as all students take calculus, and we know sine will be positive, cosine will be negative, so cosine's negative, sine's positive. So this point here will be negative radical 3 over 2, 1/2. Okay, question 5. How long will it take for an investment of $1,000 to double in value if the interest rate is 7.5% per year compounded continuously? The continuous compound interest formula is A equals P times E to the RT. If it's a finite amount of times that it's compounded, then you would use the formula A equals P times 1 plus R over N to the NT. A way to memorize this, a lot of people call it PERT. Just remember it's to the RT, right? So the principal value is 1,000. That's just your initial amount times E. 2, it says your interest rate is 7.5%. So we have to convert this to a rate by moving the decimal over 2 places to the left. So it's going to be 0.0075 T. So we have a formula. We want to know when this will double. So double 1,000 is going to be 2,000. We could divide by the 1,000. And we're actually going to see that rate that it's going by, which is double. And then we could convert to a log base form. So log base, some students like to memorize it as answer, or some say, the technical term is argument. Log base argument equals exponent. The base is attached to your exponent. So log base E of, the reason students like to memorize it as answer is it's on the other side of the equal sign. So they think of it as an answer. Log base E of 2 equals the exponent 0.0075 T. We could divide by 0.0075 to solve for T. And then just put that in our calculators. If you have log base E, that is your natural log. So T actually equals ln of 2 over 0.0075. Put that in your calculator. and you end up getting 92.41962407. Round to the nearest 2 decimal places, so that will be 92.42 years. Okay. Now for question 6. It says find the radius of a circle if the area of the sector is 10. They give you... Okay. So if you're using the area of a sector, you're going to use the area of a sector formula. Okay. Which is 1/2 r squared times theta. Theta must be in radians. So we're going to do the area is 10 equals 1/2 times the radius. Because we're trying to find the radius, we'll leave it as r squared. And then the angle is 0.8 radians. So that's like saying r squared times 0.4. And then you could divide by 0.4. 0.4 is just 4/10, right? So then 10 divided by 4/10 is like saying 10 times 10 over 4, which is 100 over 4. And then lastly, take the square root of both sides, and you would get r equals 10 over 2, which equals 5. So your radius would be 5. Okay? It says find the exact value of the reference number for t equals 5. Something you could think to yourself, pi is approximately 3.14, so it'll likely be in quadrant 3. A way that you could check this is you could convert to degrees. So if this is in radians, we know radians typically has pi in it. To convert to degrees, we want to get rid of the pi, so you're going to divide by pi. So it's 180 over pi, and then 5 times 180 divided by pi is 286.4788976 degrees. That's between 180 and 270. So if it's in quadrant 3, the way we find the reference angle is you would take the bigger number and you would subtract it from pi. Oh, I see. I'm sorry. It's 286. So if it's 286, that's in quadrant 4. If it's in quadrant 4, you would take 2 pi and you would subtract the 5. So it's 2 pi minus 5. Okay? Yeah, definitely. I would definitely convert from radians to degrees, just so you know where it lands. It's hard to think about when it's numbers and then there's some that are still in terms of pi. So yeah, that is 2 pi over minus 5. If log base b of 5 equals 1.5 and log base b of 2 equals 0.6, find the following. So this will be your product law because there is multiplication inside the logarithm. So that means you could actually separate by addition. So I'm going to separate what's being multiplied inside by addition. Okay. This b is an exponent of 1. This b is an exponent of 1. 1 divided by 1 is 1. Plus log base b of 10. We're given 2 and we're given 5. So we could show 10 as 5 times 2. We're going to use our product law one more time. So log base b of 5 plus log base b of 2 plus 1. And now we could plug in the values we're given. 1.5 plus 0.6 plus 1. It's 3.1. So your answer would be 3.1. Now, in this case, the big operation I'm noticing at first is division. So we're going to use our quotient law. So it's actually the opposite of your product law. If you had multiplication, you separate by addition. If you have division, you separate by subtraction. So that's the same as saying log base b of 25 minus log base b square root of 2. We have a 5, right? So if we have a 5, I could show this as 5 squared. Log base b of 5 squared minus log base b of a square root is just the 1/2 power. So 2 to the 1/2. And now because I have exponents, that's now my power law. So if you have an exponent within your log, you could bring it to the front and separate by multiplication. So 2 times log base b of 5 minus 1/2 times log base b of 2. And now it's just a matter of plugging in the values. 2 times 1.5 minus 1/2 times 0.6. So that would be 3 minus 0.3. Which is 2.7. Okay. For these, you have your identities, or that you're given these identities that you have to prove. Which ones are identities? So, immediately, I see these, conjugates. I'm going to think to myself, I'm probably going to have to multiply by the conjugates. So I'm going to multiply by 1 minus cosine of x, because it's also rational and we want to have a common denominator if we're going to be adding. So this is going to be by the other denominator, 1 plus cosine x. Alright? And because you're multiplying by 1, you don't have to do anything on the other side because it's the same equation. So we have sine x times 1 plus cosine x plus sine x times 1 minus cosine x over, and this is conjugate, so you have a difference of perfect squares. So we have 1 squared, which is just 1, minus, because the difference of perfect squares, cosine squared of x. This looks a lot like my Pythagorean identity. So, as a little rough work on the side, I'm going to state my Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And then I have to think, how could I get it to be 1 minus cosine squared? I could just subtract cosine squared on both sides. So I have sine squared theta equals 1 minus cosine squared theta. I could do a little substitution and plug in sine squared of theta. I'll also factor out the sine x. So I have sine x. That would be 1 plus cosine x plus 1 minus cosine x over, we said that we're going to plug in sine squared of x, yeah, in this case. So 1 sine would cancel out, and then there's nothing really happening on the parentheses, so you could drop them. Cosine x minus cosine x, 0. 1 plus 1 equals 2. So we have 2 over sine x, which equals 2 cosecant x. So the way I would show my work then, because we did all the left sides, is I would just restate the right side of the equation. Negative 2 cosecant x, negative 2 cosecant x, negative 2 cosecant x, negative 2 cosecant x. Are those the same? No. One's positive, one's negative. So 1 is not an identity. Okay? Alright. For the sake of room, I'm going to erase this, and then we'll do the second identity. So for this one, I have this. I would put all my reciprocal functions in terms of sine and cosine, or tangent if you need, but I would probably do sine and cosine. So cosine of y plus 1 times cotangent of y would be 1 over tangent of y, which tangent sine over cosine, so if it's 1 over sine over cosine, cotangent is cosine over sine. Minus cosecant is 1 over sine. Okay. Equals negative sine y. So I could actually combine, because I have a common denominator. So I have cosine of y plus 1 times cosine of y minus 1 over sine of y equals negative sine of y. Remember, this is a denominator of 1, and since the multiplication, we're just multiplying. These are conjugates, so you're going to have your difference of perfect squares. So cosine squared of y minus, because it's difference of perfect square, 1 over sine of y equals negative sine y. And now, again, this looks like my Pythagorean identity. So we have sine squared of theta plus cosine squared of theta equals 1. If I want it to look like this, I could subtract 1, and then I could subtract sine squared of theta on the other side. So I have negative sine squared of theta equals cosine squared of theta minus 1. So I'm just going to plug in negative sine squared theta on top. And I'll use y because they're using y. So 1 sine will cancel out from the denominator and numerator, and you're left with negative sine y equals negative sine y. So only 2 was an identity. Be very careful with your signs, because on that first one, most of your work could have still been correct, and you still could have gotten it wrong. because you had to remember that the negative on the one side, there was a negative on the one side. So, question 10 says, given this function, f of x equals e to the x minus 1, find the x-intercepts of its graphs. An x-intercept is where y equals 0. So you just have to plug in 0 for y. Isolate your base. You can use logs. Log base answer equals exponent. In this case, it's base e, so you could just go straight to natural log, ln, of the log base answer or argument, it's always on the other side of the equal sign, equals the exponent x minus 1. Add 1. Put this in your calculator. ln of 4 plus 1. X equals 2.386. 294361. It said accurate to 2 decimal places, so x is approximately 2.39. They did say if there was no solution to type no solution. The only way you would have no solution is if the horizontal asymptote of -4 was a positive and not negative. If I said plus 4, the horizontal asymptote would be at 4, and therefore it would look like this and would not cross the x-axis. Then you would have no solution. Okay? Question 11. Write the following in the order from smallest to largest. Okay? So, what you should know is the domain and range of these functions. Really the range, but if you have sine, arcsine, you have arccosine, and you have arctangent, or the inverse of those, you could also call it that. The range is going to be negative pi over 2 to pi over 2. For cosine, it's 0 to pi. And for tangent, it is the same as sine, negative pi over 2 to pi over 2. So it says, write the following in the order from smallest to largest. We have to think to ourselves, this is basically saying cosine of theta equals negative radical 3 over 2. We have to think to ourselves on the unit circle, where does cosine equal negative radical 3 over 2? So we know 3, 2, 1, 1, 2, 3. All of them are over 2. And then all of them have a square root in the numerator. You don't have to include it with 1, because 1 is the square root of 1 is 1. So cosine is your x values. So that's going to be for pi over 6, right? So we know it's going to be the reference angle of pi over 6. And we have to think to ourselves, all students take calculus. So cosine would not be positive here in quadrant 2 and here in quadrant 3. And the range for arc cosine is 0 to pi. So the one we have to consider is quadrant 2. So we're looking for this angle with a reference angle of pi over 6, you would take pi and subtract pi over 6. Pi is the same as saying 6 pi over 6, which would be 5 pi over 6. So this is 5 pi over 6. Next, arctangent. For arctangent, we know that it would be negative radical 3. For tangent is radical 3 at 60 degrees. If you don't memorize your tangents, you could always just do sine over cosine. So for 60 degrees, I'll show it, but obviously it would be some guess and check work if you don't have it memorized. Radical 3 over 2 divided by 1/2 would be radical 3 over 2 times 2 over 1. 2 cancels out, you get radical 3. So tangent would be radical 3 for pi over 3. But this is a negative. So all students take calculus. We have to consider here, where sine is positive because tangent would be negative, and here, so quadrant 2 and quadrant 4. And then we think to ourselves, well, tangent is from negative pi over 2 to pi over 2. So that would be from negative pi over 2 here to pi over 2. So it has to be in quadrant 4. So going in the counterclockwise direction, you would go from 0 minus pi over 3. You get negative pi over 3. So theta here is negative pi over 3. And now for arcsine of negative 1/2, sine is 1/2 at pi over 6. We have negative 1/2, so that's going to either be in quadrant 3 or quadrant 4. Sine is from negative pi over 2 to pi over 2, so that's from here to here. So it would only be in quadrant 4 then. So we said it was going to be reference angle pi over 6. You could just subtract pi over 6 from 0, because we're going clockwise now. Negative pi over 6. Alright? So, obviously the positive answer, 5 pi over 6, is going to be the largest, right? So arc cosine of negative radical 3 over 2 will be the largest. Alright? Then pi over 3 is a larger value than pi over 6. So if it's negative, that's going to be even smaller. So arctangent will be the second, will be the smallest. So arctangent will be the smallest. And then following that would be arcsine. So your answer would be this. Okay. All right. Question 12. So I like to see where there's asymptotes. I like to see where the function equals 0. An asymptote is where the denominator equals 0. So there's a vertical asymptote here at pi over 2. There's a vertical asymptote here at 3 pi over 2. So pi over 2, 3 pi over 2. So at pi over 2 we have the point 0, 1. At 3 pi over 2, it's 0, negative 1. The x value is 0. So your denominator, because it doesn't exist, it has to be where the denominator equals 0. will be where cosine, because that's the x value, where cosine equals 0. So cosine of x. Now, these functions, I mean, this is just a rational function. It doesn't really look like a trig function, right? So, like, there's no spot where the function hits 0. So it's just going to be 1 over cosine of x, which is secant of x. So for A, you have secant of x. All right. For B, we have our basic tangent function, right? Tangent is sine over cosine. So if you look, it is wherever cosine is 0, there's a vertical asymptote. Wherever sine is 0, there is a x-intercept. It equals 0 there, right? That's tangent. And that's what your tangent function looks like. You also might know that the tangent function has a period of pi, right? And it's usually symmetrical across the y-intercept. Unless, obviously, there is a phase shift. And now, lastly, again, we're going to look where we have, and we said tangent, right? And I think you selected tangent. So then for C, there's an asymptote at 0, there's an asymptote at pi, right? So that means the denominator would have to be 0 at pi. This point right here is -1, 0. At 0, this point is 1, 0. So it's where sine is 0, right? So we're going to have over sine. And then we have these zeros at pi over 2. So that means your numerator equals 0 at the trig function of pi over 2. That equals 0. So we said at pi over 2, cosine is 0. So we have cosine of x over sine of x, which is cotangent. Alright, it's the reciprocal of sine. Reciprocal of tangent. So 1 over tangent, cotangent. So this is y equals cotangent. Okay? Now for question 13. We have to find the difference quotient. So you're just going to plug in 6 plus h, plug in 6, and subtract, and then divide by h. So I have 6 plus h squared minus 6 plus h plus 1 minus 6 squared minus 6 plus 1 over h. Let's distribute this out. I have 36 plus 12h plus h squared minus 6 minus h plus 1. And then I could also distribute out the negative here as well if I wanted. So then I have negative 6 squared, or negative 36, positive 6, negative 1 over h. So now we could cancel out the 36 minus 36, the negative 6 and the 6, the 1 and the 1. I have h squared plus 12h minus h, which is 11h, over h. Could factor out the h so in the numerator, so h plus 11 over h. H cancels out, and you have h plus 11 as your answer. Okay, I guess the key to this question is to be very organized with your work. I mean, when you have a lot of terms like that, you could combine like terms, or maybe use different underlines for different like terms, groups. All right. For 14, find the value of the trigonometric function of cotangent equals 6 radical 13 over 13. Cotangent, so for tangent, tangent is opposite over adjacent, right? So cotangent is going to be the reciprocal of that. So you can say that this is your adjacent, this is your opposite. We have a right triangle. We said our adjacent is 6 radical 13. Our opposite is 13. And since we're doing all the trig functions, we're going to need our hypotenuse. So we use Pythagorean's theorem. 6 radical 13 squared plus 13 squared equals x squared. Take the square root of both sides. We would have 6 times 13, 78 plus 13 squared. 36 squared, 36 times 13. 36 times 13 plus 13 squared. 637. I could check if there's a factor that's a perfect square in there. 7 and 91 are factors. 49 and 13. So 49, 13, and then we have 7 radical 13. So if we're trying to find sine, you're going to do opposites over hypotenuse. So 13 over 7 radical 13, which you could multiply by 13, square root of 13 if you'd like. So then the square root of 13 times square root of 13 is 13. The 13 cancels out. You would get square root of 13 over 7. Okay. And obviously, if this is in quadrant, well, cotangent is positive, so it could either be in quadrant 1, or it could be in quadrant 3, right? It seems like if this is the right answer, it would be quadrant 3. Oh, it says quadrant 3. That's why. I didn't see quadrant 3. So because it says quadrant 3, you would have done exactly what we just did, just drawn it in quadrant 3. And then you do all students take calculus, and then because tangent's positive, it's going to be negative. Because tangent positive, cosine's negative, and then for tangent, it would be positive. Or cotangent would be positive as well. So, for cosine, that's going to be adjacent for cosine, that's going to be adjacent, so 6 radical 13, over hypotenuse. 7 over radical 13 cancels out. All students take calculus. Quadrant 3 is negative, so negative 6 over 7. So your answer would have been this. Okay? Question 15, we have this logarithmic function. This would be a shift, because it's x plus 4, right? That would be a shift left 4 units. This would be the same as saying negative x plus 4, which is the same as saying negative x minus 4. So this one actually would do two transformations. It would reflect over the y-axis and then shift right 5 units and 4 units. This shifts up 4 units and this shifts down 4 units. So it didn't shift left or right because the vertical asymptote of x equals 0 would have shifted with it, and it didn't. So we could immediately eliminate where the shifting right and the shifting left one. And then typically your log would look like this. At 1, it would be 0, and then it would, slowly go up. So it looks like this shifted up. So the only one that shifted up was this one. Okay. Question 16. To find the distance across a river, a surveyor chooses point A and B 100 meters apart. All right. And a reference point C across the river. So we have C here, we have lowercase a here, we have lowercase b here, the opposite of the angles. So then angle A is 54 degrees. Angle B is 77 degrees. So that means we could find angle C. The angles of a triangle add up to 180. You'd get 49. We said that this was 100 meters apart. So now that you have an angle across from a side and you have all the other angles, you can actually solve for the distance between A and C. So you're going to choose 77 to B and 100 to 49. So we're going to use our law of sines. The law of sines is sine of A over A is equal to sine of B over B equal to sine of C over C. You just need 3 pieces of that information. You need 2 angles and a side, or you need 2 sides and 1 angle. And obviously they have to be corresponding. So we have 100, so sine of 49 over 100, because sine of the angle over the side, equals, and we want to find this B side, right? So sine of 77 over B. Because you have fractions across from an equal sign, you can cross multiply. So B times sine of 49 equals 100 times sine of 77. I'm going to divide by sine of 49. So I have 100 times sine of 77 over sine of 49. Let me make sure I'm in degree mode. I am. Enter. And I get approximately 129.1 meters. 52996. All right. Question 17. Remember, y equals a cosine of b times x minus c plus d, right? So first your period is going to be 2 pi over b. So period equals 2 pi over b. Pi over 16 is attached to the t where b is. So it's 2 pi over 16, which is 2 pi times 16 over pi by keep change flip. Pi's cancel out. 2 times 16, 32. So your period is 32 seconds. Now your wave height, that is between the trough and the crest. So the midline is at 0 because there's nothing being added. There's no plus d. So we'll split it down the middle. Your amplitude is 3. That is the vertical distance between your extrema to the midline. So that's 3, and that's 3. So together, the vertical distance would be 6. So 6 feet. That's question 17. Question 18. You have a 1,000 foot cliff. You need the angle of depression. So we're going to create a right triangle going facing down of 2 cars. So this is 1 car. And then let's say we have another car here. Okay. So this is the right angle. This is 1,000 feet. This is 1,000 feet. And then the longer triangle will have the more mellow angle. So that's going to be 21 degrees. Whereas the steeper angle is 28 degrees. So now I can use my law of cosines. Because think about it, I have an angle for both. I have 2 angles, so I could find the others angles. So let's do the big triangle first. We have 180 minus 90 plus 21, right? Because we have this 21 degree angle, we have this 90 degree angle. So I have 180 minus 90 plus 21, which is 69 degrees. I could do the same thing here. I have 180 minus 28 plus 90 degrees, which is 62 degrees. So now I could actually find the horizontal lengths, right? So for the bigger triangle, I'm going to find this. I'll call this x1 if you'd like. And for the shorter triangle, we're going to find this length. And we'll call this x2. So our law of cosines, our law of sines, we have sine of 21 over 1,000 equals sine of 69 over, and this is the big one, x1. Cross multiply and then divide, which will lead to x1 equals 1,000 sine of 69 over sine of 21. Make sure you're in degree modes because they're using degrees. And that is approximately 2,605.089065. So now we're going to do the same thing for the smaller triangle. So, sine of 28 over 1,000, all right, equals sine of 62 over x2. Cross multiply, you get x2 equals 1,000 times sine of 62 divided by sine of 28. And you get x2 is approximately 1,880.726465. So now I just have to do x1 minus x2. So we have 2,605.089065 minus 1,880.726465. Subtract those two numbers, and you end up getting 724.3626. To the nearest, round your answer to the nearest 10th place, 724.4 would be your answer. Feet. Okay? $724.4 feet. Okay. For this question, it says write in interval notation the domain of the function. The way you find the domain of a log, you set the argument greater than 0. The argument's what's in the parentheses. 9 minus x squared is greater than 0. Subtract 9 on both sides. Negative x squared is greater than negative 9. Divide by negative 1. We get x squared. We get positive 9. And because you divide or you multiply by a negative, you must flip the sign, the inequality sign. And then you could take the square root of both sides, and you would get, when you have a quadratic inequality, what I would do is I would maybe set it equal to 0. I wasn't really paying attention, I didn't realize it was 0. I would set it equal to 0, and then you would get plus or minus 3. It's not equal to plus or minus 3, but you just found the zeros. So now, you have to think to yourself, this is a quadratic in here, right? So you could do a quick rough sketch. Negative 3, positive 3. And it's a negative leading coefficient, so it's concave down. So I would separate those with lines, right? And now, we want to know where this is we want to know where 9 minus x squared is greater than or equal to 0. So, because we set our argument greater than 0, so that would be where it's above the x-axis. It's above the x-axis here. It would be below the x-axis here. So, in interval notation, it would be between negative 3 and 3. We say our argument's greater than 0, not greater than or equal. So we have to use parentheses. Negative 3 to 3. Okay. Question 20. Secant squared of x minus 4 equals 0. Add 4 to both sides. Secant squared of x equals 4. Take the square root of both sides. Whenever you take the square root of an unknown, you must include plus or minus. Secant of x equals plus or minus 2. secant is the same as saying 1 over cosine of x equals plus or minus 2. You could take the reciprocal of both sides. So you would get cosine of x equals plus or minus 1/2. And now I would separate this into two problems. Where is cosine of x equal to negative 1/2? Where is cosine of x equal to positive 1/2? So what you're going to do, think of your unit circle, right? Cosine is the x value, so it goes 3, 2, 1. So that would be pi over 3. So we're going to look for every reference angle of pi over 3 now, right? So pi over 3, pi over 3, pi over 3. These are the reference angles I'm drawing. And we could also consider all students take calculus. So for the negative, we're talking about here, because there's a sine and there's a tangent. For the positives, we'll talk about quadrant 1 and quadrant 4. So for positive 1/2, we already know pi over 3. We also have here, in quadrant 4, you would do 2 pi minus pi over 3, which is the same as saying 6 pi over 3 minus pi over 3, which is 5 pi over 3. Okay? And I'll write them like this, and you'll see why in a moment. So, for the negatives, you would do pi minus pi over 3. So that's the same as saying 6 pi over, 3 pi over 3 minus pi over 3, which is 2 pi over 3. And then, in quadrant 3, you would have pi plus pi over 3. So that's like saying 3 pi over 3 plus pi over 3. So you would have 4 pi over 3. So now, we have to think to ourselves, it isn't just these angles, right? These are the angles between 0 to 2 pi. So, if it comes back around, you're going to have coterminal angles. And to get coterminal angles, you would add by 2 pi, right? But you could add by as many 2 pi's as you want. So, I'm going to use the letter K because it seems like they're using the letter K. And then this would be all of your solutions. Every possible solution. So, we have pi over 3 plus 2k pi. That's right here. We have 2 pi over 3 plus 2 pi k. We have 4 pi over 3 plus 2 pi k. And we have 5 pi over 3 plus 2 pi k. Alright? Hopefully that makes sense. Question 21. We are given this. We want to find the inverse. The first step to finding an inverse is switching x and y. So personally, I like to define f of x as y. And then just writing it. Y equals 5 times e to the x minus 4. This step is optional. You could just write y equals. And now, and that's still your original function. Now you're going to switch your x and y. So we have x equals 5 times e to the y minus 4. And the moment you start there, that's your inverse function. The minute you switch your x and y, that's your inverse function. But typically, we solve for functions in terms of y. So to solve for an exponent, we have to use logs. Isolate your base. Convert to log base form. So log base e, so that's ln, of your answer on the other side of the equal sign, x over 5, equals your exponent, y minus 4. Add the 4 to both sides. and we get y equals ln of x over 5 plus 4. But remember, this is your inverse function, not your original. So rather than calling it f of x, we're going to call it the inverse of f of x. And that is your answer, ln of x divided by 5 plus 4. Okay? Question 22. Find the exact value of, given f of x and g of x, find the exact value of the function composition. So, you could find f of 9 first. So f of 9 equals the square root of 9 plus 6. I just plugged in 9 to f, which is the square root of 15. Now, we have to do this of g. So we're going to be doing g of the square root of 15. So you're going to plug in the square root of 15 wherever you see x. So square root of 15 squared minus 16. That would be 15 because square root cancels out the square. Minus 16 equals negative 1. So that's your answer. So if this was a short response, I would probably rewrite the question and say the function composition at x equals 9 equals negative 1. Alright? Strontium 90 decays according to this. How much is present after 50 years? T is in years, so you could just plug in 50. So I'm just going to put this on my calculator. 45 times e to the negative 0.0241. And then I'm plugging in 50 for t. I end up getting 13.486139998. Round to one decimal place, so it's approximately 13.5. If you have to give in units, milligrams, so mg. After how many years will 27 milligrams remain? So we want to know when now, rather than the amount. So we have the amount of milligrams. Isolate your base. Take the log. Log base e, so it's ln, it's your natural log, of 27 over 45 equals the exponent. Divide by the negative 0.0241. And you'll get your answer. So ln of 27 divided by 45 divided by negative 0.0241. You end up getting t equals 21.1960837, which is approximately, round your answer to the nearest whole number. So t is approximately 21 years. And then, what is the half-life of strontium? Round your answer to the nearest whole number. This is when you're going to have to know what a negative exponent is. So you have m equals 45 e to the negative 0.0241 t. Let me just make sure that's what it says. Okay. So this is your initial amount. This is the time, right? And we're saying that this is a half-life, right? So e to the negative 0.0241 equals 1/2 to the x. Okay? So we want to find what that fraction is. as an exponent. So you're going to log base answer equals exponent. You get x equals 0.0347689,505. Something else you actually could have done. What we're doing isn't incorrect. This is approximately, 3 out of 100 plus 4 out of 1,000 plus 7 out of 10,000 plus 6 out of 100,000, right? Right now I'm estimating what it's about. It's not gonna convert to a fraction for me. No. But I'm gonna do an easier approach. So let's do a much easier approach. So something you could do is you could say, well, this is going to have at a certain point. So we're going to get 45 over 2 here. Divide by 45. Should get 1/2 times. Yep, you get 1/2. Equals e to the negative 0.0241t. You would do log base e, so ln, of your answer 1/2 equals the exponent. And then you could divide by the negative 0.0241. So I'm going to do ln of 1/2 divided by negative 0.0241. T is approximately 28.7612938. So that is, to the nearest whole number, 29 years, the half-life. That was a much easier way of doing it. Okay, so now question 24. You're given A, you are given B, you are given C, and that's all you're given, right? So if you're given side, 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 you're not given an angle, you're going to have to use law of cosines. So I have a squared plus b squared equals, minus 2ab cosine of c, where c squared equals this. We're trying to find theta, which is b, right? So adapt the formula. B squared equals a squared plus c squared minus 2ac cosine of b. So then I have to plug in. B is 36 squared equals A is 69 squared plus C is 43 squared minus 2 times 69 times 43 times cosine of b. We're trying to solve for cosine of b. So I could subtract the 69 squared. I'll show it. 69 squared on both sides. Could subtract the 43 squared on both sides. And then I could divide by this. Negative 2, 69, 43. Okay. So I have cosine of b equals 36 squared minus 69 squared minus 43 squared over negative 2 times 69 times 43. If I want, I could actually get rid of the negative, right? So the negative, make this negative, make this positive, make this positive. And then, if I want to solve for b, I just do the inverse. So cosine, inverse of cosine or arc cosine of negative 36 squared plus 69 squared plus 43 squared over 2 times 69 times 43. Put that in your calculator. So second cosine let's put parentheses on those. No, don't put parentheses on that. Negative 36 squared, because the negative was on the outside, plus 69 squared plus 43 squared over 2 times 69 times 43. Alright, and I get my answer is 26.42503,974 to 1 decimal point place, approximately 26.4 degrees. Alright, that's question 24. 25. Looks like the question we did earlier, right? So, there's division, so use your quotient law. You separate by subtraction. Make sure to carry your base over. Now I have, you're given 7, you're given 3. 27 is 3 to the third. So log base y of 3 to the third minus log base y of, there's multiplication, so you could separate by addition. Now this is where a lot of students make a mistake. This is negative of this entire value. So you're not making it negative of part of the value. So you need a parenthesis around the whole thing. I can bring the 3 to the front by the power law. Actually, oh, never mind. We're good. Bring it to the front. I'm going to multiply this out. Negative log y is 7. The exponent on the y's are 1 and 1. It's common base. So 1 divided by 1 is 1. So we're going to have negative 1. And now log base y of 7 is 3.2. And log base y of 3 is 1.8. And then we just have to solve that. So 3 times 1.8 minus 3.2 minus 1. You get 1.2 as your answer. Okay. 26. Use your sum and difference formulas. Remember your sum and difference formulas, right? You have sine of theta plus or minus phi equals, with sine, it's the same sign. So if it's plus or minus, it's going to be plus or minus. And then same sign, but alternating sine and cosine. So sine theta, cosine phi, sine phi, cosine theta. For cosine, we have cosine of theta plus or minus phi, but with cosine, it's not the same sign. So if it's plus or minus, it's going to be minus or plus. And then you're going to double on the cosine, double on the sine. So cosine theta, cosine phi, sine theta, sine phi. So that's your sum and difference formulas for sine and cosine. This is a double cosine, double sine. So clearly, this is going to be the cosine one, right? Double cosine, double sine. We'll label this as our theta. We'll label this as our phi. And because it's cosine, it's going to be the opposite sign. So there's a negative, so it's going to be plus. So we have cosine of theta. And then we said it's opposite sign. So if it's negative, it's going to be plus pi over 8. And now it's just a matter of simplifying. So this is like saying 6 over 8, right? 6 pi over 8 plus pi over 8, which is cosine of 7 pi over 8. So your answer would be this. Okay? 27 for the triangle, find the length AD. So you want to find this. So we have 23. Okay, you have 23 and 11. You have 11 and C. So you could use your law of sines. Sine of 23 over 11 equals sine of C over 11. Because this is isosceles. It's 11 and it's 11, right? So you would have sine of C equals 11 sine 23 divided by this 11, right? The 11s cancel out. Sine of C equals sine of 23. Oh, that's another thing you could know. So C has to be 23, right? The reason you know this, that's also called your isosceles triangle theorem. So, with isosceles triangles, if you have the same side, the angles across from those sides are the same. But it was cool that we were able to show it two ways. And now, you have 23 and 23. You know the sum of the angles of a triangle are 180. So we have 180 minus 23 plus 23, which is 134. So now we have 134 here. This is a supplementary angle, right? They are straight angles. So 180 minus 134 equals 46. And now, let me be a little neater. We said 23. We said 134. We said 46. And we know this is 23. So then 180 minus 46 plus 23 equals 111. So now we have an angle on a side. We could actually just an angle on a side, and we have the angle. We could use our law of sines. So sine of 23 over x equals sine of 111 over 11. Okay. So x equals 11 sine of 23, cross multiplication, right? Over sine of 111. Let me make sure I'm in degree. I'm still in degree mode. A lot of this was in degree mode. 11 sine of 23 divided by sine of 111. And you get your answer is 4.603826614 to the nearest hundredth is approximately 4.60. Alright, so that's 27, 28. We're going to do arctangent of -2. That's essentially saying tangent of theta equals -2. Has to be the exact value. Okay. So we have theta. Opposite will be, you're going to have to use, I mean, your opposite is -2. Your adjacent is 1. Oh, I see. That's why. Okay. So then we're going to solve for the missing length. A squared plus b squared equals c squared. So I have 1 squared plus -2 squared equals x squared, square root of both sides. So 1 squared plus -2 squared. 1 plus 4 is 5, square root of 5. So we have all the values of the triangle, right? Based off that tangent. So now we just have to, based off this data, so now you just have to find cosine. Cosine is going to be adjacent. So the adjacent's 1 over hypotenuse. Radicalize your numerator. Radical 5 over 5. Alright? It doesn't give a quadrant. Alright. So now we're going to do the same thing with this one. So cosine is adjacent over hypotenuse. Didn't really have to include the negative. So cosine is adjacent over hypotenuse. So then we're going to have to find the opposite side. So we have -3 squared plus x squared equals 4 squared. We could subtract the 9 on both sides. X squared equals square root. You take the square root of both sides. 16 minus 9 is 7. So you get x equals square root of 7. So then because you have those values, you could just find sine now. So the opposite would be square root of 7 over the hypotenuse 4. And then that's your answer. Okay? Now for question 29. graph which of the function is given below. So, unfortunately, there is a shift, right? So I would factor out the 2, right? So you're going to divide out 2, but also show the equivalent product. So we have 2 of x minus pi over 8, 3 of cosine of 2 of times x minus pi over 8, 3 of sine times 2 of x plus pi over 8. And then we have negative 3 of sine 2 times x minus pi over 8. So we know sine looks like this. Cosine, positive cosine looks like this. Positive sine, again, looks like this. And then negative sine looks like this. Alright? So, it looks like if you wanted to start maybe at cosine, right? We start at the maximum, and we return at the maximum right here. You would typically separate this into 4 intervals, right? You split up your period into 4. So knowing they didn't give you much information, but they did give you 7 pi over 8 and 3 pi over 8. So if that's only 2 intervals, you could do 7 pi over 8 minus 3 pi over 8. And then you're going to divide that by 2 to see what the sketch point is. You can multiply by 2 to get the period. So then we have 7 pi over 8 minus 3 pi over 8, 4 pi over 8 over 2. That's the same as saying 4 pi over 8, or I'll make it pi over 2. Pi over 2 times 1 over 2, which is pi over 4. So then this here is pi over 4. This here would be pi over 4 plus 3 pi over 8. I mean pi over 4 plus pi over 4. I mean, it definitely shifted over right pi over 4. So then you have 3 pi over 8. Okay, I mean, we already found what it shifted by. It shifted by pi over 4, and it looks like it shifted right pi over 4, which means if it's going right, it has to be negative. So the ones with the positive, we could cancel out. And that's your cosine function because it starts at the maximum. Alright? Yeah, and all the other information is the same. So amplitude is 3. Alright? And you could find your period and then, see if it matches the b using the period formula 2 pi over b. But overall, that would be your answer. It would be 2. And the way we were able to tell that was from the phase shift. And also, it very clearly, just from the phase shift. And the fact that it shifted over here and then there was a maximum that it started at. Alright? And then according to her practice quiz, it says This was not a complete review, so I definitely recommend checking out the other 3 videos on the department final review. Okay, thank you. Have a good night.